Hello everyone, I am Professor Nayanasni, Department of Information Technology, Bharati Genba Mose College of Engineering, Vagoli. So in this session we will start with a state diagram. We can also call it a state chart diagram or state machine diagram. So state diagram is used to represent the condition of the system or a part of the system at the finite instance of the time, that is for the particular duration. So it is a behavioral diagram and it represents the behavior using the finite state transitions. So the state diagram can be also referred as the state machines or the state chart diagrams. So there is a basic difference between the flow chart and the state diagram. You can see in the flow chart we have proper instructions, we have proper commands to flow from one state to another. Here in a state diagram we will not find some states, some commands or some process or some instruction flow from one activity to another or from one state to another. In a state diagram we have the change in the state of the object. So depending on the object state changes, the flow or we can say the transitions goes from one state to another. So that is a basic difference between the state and the flow chart, because both are quite similar to see, or they both quite similar look like, but there is a difference. Flowchart will always move from one activity to another depending on the instruction, depending on the commands, or depending on the process, how the instructions are flowing. But in a state diagram, transitions only occur when there is a change in the state of the object. We'll see it in the example, you will get to know. So we'll see first the components of the state diagram, as we have previously also seen this. So the initial state always starts with the solid symbol, that is a solid circle, that is starting of the state chart diagram, or we can say state machine diagram or simply state diagram. So second is a transition, that is nothing but a solid line. If some event occur, if some interrupt is there, if some timer is there, so one state changes, one object of the state changes its state. So suppose the object is on one state, some timer is occurring, so it will change its state. So that is the transition in the state chart diagram. Next one, third one is the state, that is nothing but the rectangular box with defining the name inside the state that represents some condition or some circumstances of that particular object. So it moves, the object states moves from one state to another dependent on some event, some interrupts, some timers. So this is the object state. These are not the actions or not the process or not the commands. These are the state of the object, the different states of the object. Then we have fork, as we have previously seen. Fork is nothing but to create the different state from one state. So it is a solid rectangular blocks with having one incoming edge and having two or more outgoing edges. That is, one state can have, or one state can create a different substate. That is nothing but the fork. And next is the join, which is just opposite to fork. That is, we have two different states, incoming edges to a single state. That is, the output of the both is combined in a single state. So that is state A for this particular example. Then there is a self transition. This is just a single move for a particular state. That is, the state is repeating itself. So we have to give a loop. Then there is a substate. We can also call it as a composite structure. Now here you can see the two things are combined here. First is the substate. That means the applying brakes is the state which is having applying front brake and applying rear brake as a substate. So it is also called as, the applying brake is also called as a composite state, and these two are called as a substates. Now there is another one point, that is a concurrent states. So if two or more states are running simultaneously, so that states are called as a concurrent state. Suppose you have to manage the brake, or you have to apply the brake immediately. So what we are doing, we are pressing both the brake front and the rear. So both actions are doing simultaneously, both are occurring concurrently. So these are concurrent state under the composite state, that is a apply brakes. So Next is the history state. That means sometimes we have to start with the previous state and remember the previous state and then start the other state. So for remembering the previous state, we have a state history. So you can see here H. Whenever the power is off, some H state is there which will reserve or which will restore the history of the previous operation, so that you will not start from the initial state. You will start from the state on which the power was off or some operation was left. So by using the history state, you can just start from the whenever you have left, you can just continue for further. So that is called as a history state, denoted by the H with the circle. Okay. Next is your entry point and exit point. That means sometimes you need not require to go with the first phase, that is the initial phase. So what we have, we can directly create an entry point and move forward in the move forward in the states. So if you take the example of the Gmail, if you have, or you can just creating your some other account for some freelancing, some other account using the Gmail, so you don't have to register for that account. What you are doing, you are logging with the Gmail. You are creating an account or login for the particular application using the Gmail. So that is your entry point. Without going for the registration for the application or for some portfolio, what you are doing, you are just log in with the Gmail. So you have to just enter your username and password and you can just enter into the application, that new one application. So that can be an entry point. That is, sometimes you won't want to enter a submachine at the initial state. For some example, in the following in this submachine, it will be normal to begin in the initialization state, but if some for reason you don't want or doesn't want necessary to perform the initialization, then it is possible to begin at the ready state directly without going for the initial. You can see here there is already initialized. If something is already initialized, for second time you don't go for the initialize, you directly will start the performing the activity. So you can see here the open symbol, that is nothing but skipping the initialization, and that is your entry point. Same as exit point. If you want to directly exit from anything before, or you want to directly exit for a particular application before going or before proceeding to the other, or being proceeding to other exit point at the end, so you can directly go to the exit point using just circle and cross in it. So it will directly out from the application without processing the whole state or whole transitions and then exiting. So you can directly exit at the point. So that is the previous exit point in the state machine. So then is the next one is the choice of pseudostate. That is nothing but the diamond condition, which has one incoming edge and different outgoing edges, or number of outgoing transition. Suppose you have to select the message format for sending to the peoples. So what we have different message format. Suppose we have to create message is one incoming edge. Here you can see the diamond, which is having the three options, three alternative ways to create a message or to select a message format. So first is you can send the voice message, you can create the text message, or you can send the fax message. It can be another one, you can send the WhatsApp message. Okay. So this can be a different ways for a single incoming edge. So that is called as a pseudo choice or the choice pseudo state. That means for the diamond condition, for the conditional statement, you can have the different outgoing edges for the different ways for a single incoming edge. So that is choice pseudo state. The next one is the junction pseudo state. That is nothing but chain of the states having the multiple transactions. That is, a single junction can have one or more incoming edges and one or more outgoing edges. So we can say, if you have to create the message or if you have to send the message, so you have number of incoming voicemails, you can have number of SMS, you can have number of fax message, or you can say the Gmail mails, or you can say the WhatsApp mails, that is coming to one point, and then we are sending or creating the voice message, we are creating the SMS, we are creating the fax. So whoever sender has fax to us, so we are also creating the fax message and sending to him. So the junction pseudo state is nothing but number of different incoming edges and number of different outgoing edges with some guard condition. So guard condition is given here: reply with voice, reply with SMS, and reply with fax. So in bracket you can say the you can see the guard condition. So guard condition is nothing but whenever you are having a condition with different alternative ways, so you are using the guard condition with a rectangular box. You can also see here the guard condition is in a rectangular box. So that is nothing but splitting the incoming edges into the outgoing edges. The next we can see the example of the state machine with the bank ATM system. Here, as we have seen in the notations also, the solid dot is the first symbol, first notations to start the state machine diagram. So first, initially we are starting with the solid symbol, proceeding with the arrow, that is nothing but the transition. Suppose first the ATM is off. Now if we have to turn on the ATM, you can just turn on by self state. So whenever you are turning on the ATM by some human interaction, so because this will be done by the security guard for handling that ATM, so first it will take a self test. So after the self state, if the self state failure, then it will show the message out of the service. Okay. If it is running fine, then it will go to the ideal state. That means it is ready to take the card. Now suppose some customer come to insert a card, then by inserting a card by the human interaction, that is nothing but the event generation from the external system, it will go to the customer service or the serving the customer state. Now here you can see this is the composite state, having the state name, having some activities which are performed under this state, and some actions. So composite state contains three parts. First is the state name, second is the activity, and third are the action. So if the card is read, then following operations can be performed, that is customer authentication, selecting the transition, whether it is just seeing the bank balance or withdrawing something, then proceeding with the transaction, and end. But if the card is rejected, so what the things will have? It will go to the cancel state. Again the ATM will be at the idle state, so the next customer can perform the operations. Or if the card is not reading properly, or if some error comes, so it will go to the out of service and it will turn off the machine. Okay. Suppose in the ideal state, if it is not giving some money, or it is out of the service, then it will from idle state it will go to the maintenance state. Under the maintenance state, if the ATM is not performing well also after the maintenance, so it will go to the failure state. Again after the failure, if it will go to the off state. If after the maintenance, after repairing the machine, it will if it is working fine, then it will go for the self test. After the self state is okay, then it will again go to the idle state. If the self test fell, then again it will go to the out of the service. So these operations, changing one state to another of the object, is performed by using some interrupt, by using some timer events, or by using some object change its states. So this states changes from one state to another, or the transition happens, the state of the object changes from one state to another by using some interaction, by events, by interrupts, some timer events. So it is not just a flow, it is some interrupts, it is some event that is occurring by the particular state of that object. So this is the state machine diagram. You can also say the state chart diagram. I hope this session is understood. So if you have any doubt, you can comment in comment box, or you can tell me in a Zoom session. Thank you.